And the faster the rate of flow, the more the hydrogen ion pumping, and the more hydrogen ions you have out here, the more of this flow back through ATP synthase can occur. And ultimately, therefore, the greater the production of ATP. And so we need ADP present, and we need hydrogen. So if we increase hydrogen, more of these ATP synthases are going to, at any given time, be able to have a hydrogen flowing through them. And it's the ATP synthases that have an available ADP and PI. And where this happens, we get the ATP production. Okay, so here I've tried to put all three of the energy systems together. And here is phosphocreatine hydrolysis, which is providing us with ATP. Here's the contractile protein site of consumption of ATP. So here's inflow 1. And we have carbohydrate going to lactic acid. And here's our ADP to PI. So this means we have inflow number 2. And again, this ATP can be utilized, in this case for contraction. And then here in the mitochondria, we have the hydrogen ion flowing back through the ATP synthase, which creates ATP. And here is inflow number 3. And so with calcium, which acts to increase ATP consumption, shown here, supply through phosphocreatine hydrolysis can increase right away, as we've discussed. Calcium activation can also play a role in glycolysis. That means that's part of what can increase glycolysis and glycolytic feed-forward activation. And finally, calcium can also activate the enzymes in the tricarboxylic acid cycle, as I've shown you, but can also activate ATP synthase. And then we have the provision of ATP. And oxygen is required, and the delivery of oxygen can have an impact on this whole system. That's for a different course.